Hello everyone. In this module, let us discuss the Gibbs energy and the relation between change in Gibbs energy, that is delta G, and spontaneity. Please subscribe to my channel, like, share and comment my videos. Now let us discuss the relation between delta G and spontaneity. Delta G is Gibbs energy. We already studied that delta S total equal to delta S system plus delta S surroundings. Now let a process takes place at constant temperature and constant pressure. Let the heat lost by surroundings be Q, which is gained by the system at temperature T, that is constant temperature T. Therefore, delta S surroundings equal to minus Q by T. Here, my negative sign of Q indicates that heat lost by surroundings, and this heat is gained by the system. So the heat lost by surroundings is Q. Since heat is lost, it is minus Q. And this heat is gained by the system at constant temperature and constant pressure. So heat gained at constant temperature is nothing but QP, that is delta H system. Therefore, delta S surroundings is equal to minus Q by T, which is nothing but minus delta H system by T. So this minus Q is nothing but a minus delta H system. Now substitute this value in the equation. Therefore, delta S total equal to delta S system plus delta S surroundings. So this is delta S total is equal to delta S system. In place of delta S surroundings, you keep delta H minus delta H system by T. So delta S total equal to delta S system plus delta S surroundings. In place of delta S surroundings, just substitute minus delta H system. Therefore, multiply with T on either side. Therefore, this is, so if we multiply this with T, we get T delta S total is equal to T delta S system minus delta H. Now multiply with minus sign. Therefore, this is minus T delta S total equal to minus T delta S system plus delta H. This is nothing but minus T delta S is equal to delta H minus T delta S. What is delta H minus T delta S? This is nothing but T delta S equal to delta G at T and P. Means Gibbs energy at constant temperature and constant pressure. Therefore, delta G at T and P is equal to minus T delta S. This is negative value. Thus, for a system to be spontaneous, the delta G must be negative. Therefore, for a system to be spontaneous, delta G must be negative. Now let us see the conditions. So here, conditions. Minus T delta S delta G. If delta S is positive, so minus into plus is minus, therefore delta is also positive or less than 0, therefore it is spontaneous. If delta S is negative, then what happens? This is minus T delta S, minus into minus becomes plus. Therefore, delta G is positive or greater than 0. Therefore, system is non-spontaneous. If delta S is 0, therefore this complete value becomes 0. Therefore, delta Z is 0. Therefore, this is 0. Therefore, the system is in equilibrium. The system is in equilibrium. Now let us see the relation between Gibbs energy change and non-mechanical work. So from first law of thermodynamics. So from first law of thermodynamics, delta U equal to Q plus W. What is W here? W may be PV work, non-PV work. So W includes PV work and non-PV work. Non-PV work means non-mechanical work. Therefore, delta U equal to Q minus P delta V plus work non-experimental. We can write this, bring these two factors to this side. Therefore, Q equal to delta U plus P delta V minus W non-experimental. This is nothing but this delta U plus P delta V is nothing but delta H. Therefore, Q equal to delta H minus W non-experimental. For a change taking place under isothermal and reversible conditions, the entropy change delta S is given by, so entropy change delta S is equal to Q by T, or Q equal to T delta S. Q equal to T delta S. So substitute this T delta S in place of Q. Therefore, here substitute this T delta S in Q here. Therefore, this is T delta S is equal to delta H minus W non-experimental. Therefore, T delta S equal to delta H minus W non-experimental. Now, bring this H to this side, or bring this T delta S to this side, this one. Therefore, W non-experimental is equal to delta H minus T delta S. Delta H minus T delta S is nothing but delta G. Therefore, this delta is G at a constant temperature and constant pressure. Therefore, minus delta G at constant temperature and constant pressure equal to minus W non-expansion. Non-expansion means non-PV work. Therefore, decrease in Gibbs energy. Decrease in Gibbs energy is equal to non-expansion work is nothing but non-expansion work done by this system. So decrease in Gibbs energy is nothing but non-expansion work done by the system. Now let us discuss the relation between standard Gibbs energy change delta G naught and equilibrium constant K EQ. Consider a reaction A plus B gives C plus D. The relation between Gibbs energy change and standard Gibbs energy change is given by, the relation between Gibbs energy change and standard Gibbs energy change is given by delta G equal to delta G naught plus RT ln Q, where R is the universal gas constant and T is the temperature, Q is the reaction quotient. R is the gas constant, T is the temperature, Q is the reaction quotient. Therefore, Q equal to product of concentrations of resultants by product of concentrations of reactants. At equilibrium, reaction quotient is equal to equilibrium constant at delta G becomes 0. So, delta Z equal to 0. Therefore, substitute these values in this equation. 0 equal to delta Z naught plus RT ln K EQ. So bring this to this side. Delta G naught equal to minus RT ln K EQ. Natural logarithm can be changed into base 10. Therefore, this equal to minus 2.303 RT log K EQ. So delta G naught equal to minus 2.303 RT log K EQ.